Sharing files with Windows users via Samba. In this section, I'll walk you through setting up your very own Samba file server. I'll also go over a sample configuration to get you started so that you can add your own shares. First, we'll need to make sure that the Samba package is installed on our server. Copy. Sudo apt install Samba. When you install the Samba package, you'll have a new daemon installed on your server, SMBD. The SMBD daemon will be automatically started and enabled for you. You'll also be provided with a default configuration file for Samba, located at /etc/samba/smb.conf. For now, I recommend stopping Samba since we have yet to configure it. Copy. Sudo systemctl stop SMBD. Since we're going to configure Samba from scratch, we should start with an empty configuration file. Let's back up the original file, rather than overwrite it. The default file includes some useful notes and samples, so we should keep it around for future reference. Copy. Sudo mv/etc/samba/smb.conf/etc/samba/smb.conf. Now, we can begin a fresh configuration. Although it's not required, I like to split my Samba configuration up between two files, /etc/samba/smb.conf and /etc/samba/sumshared.conf. You don't have to do this, but I think it makes the configuration cleaner and easier to read. First, here is a sample /etc/samba/smb.conf file. As you can see, this is a really short file. Basically, we're including only the lines we absolutely need to in order to set up a file server with Samba. Next, I'll explain each line and what it does. Copy. Global. With the global stanza, we're declaring the global section of our configuration, which will consist of settings that will impact Samba as a whole. There will also be additional stanzas for individual shares, which we'll get to later. Copy. Server string equals file server. The server string is somewhat of a description field for the file server. If you've browsed networks from Windows computers before, you may have seen this field. Whatever you type here will display underneath the server's name in Windows Explorer. This isn't required, but it's nice to have. Copy. Workgroup equals workgroup. Here, we're setting the workgroup, which is the exact same thing as a workgroup on Windows PCs. In short, the workgroup is a namespace that describes a group of machines. When browsing network shares on Windows systems, you'll see a list of workgroups, and then one or more computers within that workgroup. In short, this is a way to logically group your nodes. You can set this to whatever you like. If you already have a workgroup in your organization, you should set it here to match the workgroup names of your other machines. The default workgroup name is simply workgroup on Windows PCs, if you haven't customized the workgroup name at all. Copy. Security equals user. This setting sets up Samba to utilize usernames and passwords for authentication to the server. Here, we're setting the security mode to user, which means we're using local users to authenticate, rather than other options such as ads, Active Directory, or domain controller, which are both outside the scope of this book. Copy. Map to guest equals bad user. This option configures Samba to treat unauthenticated users as guest users. Basically, unauthenticated users will still be able to access shares, but they will have guest permissions instead of full permissions. If that's not something you want, then you can omit this line from your file. Note that if you do omit this, you'll need to make sure that both your server and client PCs have the same user account names on either side. Ideally, we want to use directory-based authentication, but that's beyond the scope of this book. Copy. Name resolve order equals bgast hosts wins. The name resolve order setting configures how Samba resolves host names. In this case, we're using the broadcast name first, followed by any mappings that might exist in our /etc/hosts file, followed by wins. Since wins has been pretty much abandoned, and replaced by DNS, we include it here solely for compatibility. Copy. Include =/etc/samba/some_shared.conf. Remember how I mentioned that I usually split my Samba configurations into two different files? On this line, I'm calling that second /etc/samba/some_shared.conf file. The contents of the some_shared.conf file will be inserted right here, as if we only had one file. We haven't created the some_shared.conf file yet. Let's take care of that next. Here's a sample some_shared.conf file. As you can see, I'm separating share declarations into its file. We can see several interesting things within some_shared.conf. First, we have two stanzas, documents, and public. Each stanza is a share name, which will allow Windows users to access the share under //server name/share name. In this case, this file will give us two shares, //server name/documents and //server name/public. The public share is writable for everyone, though the documents share is restricted to read only. The documents share has the following options. Copy. Path =/share/documents. This is the path to the share, which must exist on the server's file system. In this case, when a user reads files from //server name/documents on a Windows system, they will be reading data from /share/documents on the Ubuntu server that's housing the share. Copy. Force user =my user force group =users. These two lines are basically bypassing user ownership. When a user reads this share, they are treated as my user instead of their actual user account. Normally, you would want to set up LDAP or Active Directory to manage your user accounts and handle their mapping to the Ubuntu server, but a full discussion of directory-based user access is beyond the scope of this book, so I provided the force options as an easy starting point. The user account you set here must exist on the server. Copy. Public =yes, writable =no. With these two lines, we're configuring what users are able to do once they connect to this share. In this case, public =yes means that the share is publicly available, though writable =no prevents anyone from making changes to the contents of this share. This is useful if you want to share files with others, but you want to restrict access and stop anyone being able to modify the content. The public share has some additional settings that weren't found in the documents share. Copy. Create mask =0664 force create mode =0664 directory mask =0777 force directory mode =0777. With these options, I'm setting up how the permissions of files and directories will be handled when new content is added to the share. Directories will be given 777 permissions and files will be given permissions of 664. Yes, these permissions are very open. Note that the share is named public, which implies full access anyway, and its intent is to house data that isn't confidential or restricted. Copy. Public =yes, writable =yes. Just as I did with the previous share, I'm setting up the share to be publicly available, but this time I'm also configuring it to allow users to make changes. To take advantage of this configuration, we need to start the Samba daemon. Before we do though, we want to double check that the directories we entered into our some_shared.conf file exist, so if you're using my example, you'll need to create /shared/documents and /shared/public. Also, the user account that was referenced in the force user and the group referenced in the force group must both exist and have ownership over the shared directories. At this point, it's a good idea to use the test parm command, which will test the syntax of our Samba configuration files for us. It won't necessarily catch every error we could have made, but it is a good command to run to quickly check the sanity. This command will first check the syntax, then it will print the entire configuration to the terminal for you to have a chance to review it. If you see no errors here, then you can proceed to start the service. With test parm out of the way, feel free to start Samba. Copy. Sudo systemcll start smbd. That really should be all there is to it. You should now have a documents and public share on your file server that Windows users should be able to access. In fact, your Linux machines should be able to access these shares as well. On Windows, Windows Explorer has the ability to browse file shares on your network. If in doubt, try pressing the Windows key and the R key at the same time to open the Run dialog, and then type the universal naming convention, UNC, path to the share, //server name /documents or //server name /public. You should be able to see any files stored in either of those directories. In the case of the public share, you should be able to create new files there as well. On Linux systems, if you have a desktop environment installed, most of them feature a file manager that supports browsing network shares. Since there are a handful of different desktop environments available, the method varies from one distribution or configuration to another. Typically, most Linux file managers will have a network link within the file manager, which will allow you to easily browse your local shares. Otherwise, you can also access a Samba share by adding an entry for it in the /etc/stab file, such as the following. Copy. //mid. In order for the stab entry to work, your Linux client will need to have the Samba client packages installed. If your distribution is Debian-based, such as Ubuntu, you will need to install the Samba client and sysutils packages. Copy. Sudo apt install Samba client sysutils. Then, assuming the local directory exists, /mnt/documents in the example, you should be able to mount the share with the following command. Copy. Sudo mount /mnt/documents. In the stab entry, I included the no auto option so that your system won't mount the Samba share at boot time. You'll need to do so manually with the mount command. If you do want the Samba share automatically mounted at boot time, change no auto to auto. However, you may receive errors during the boot if for some reason the server hosting your Samba shares isn't accessible, which is why I prefer the no auto option. If you'd prefer to mount the Samba share without adding an stab entry, the following example command should do the trick. Just change the share name and mount point to match your local configuration. Copy. Sudo mount tsif //measurver /documents o username equals my user /mnt/documents.